Good evening, and I welcome you, students. Amazing class, amazing session, and very important session. Image formation by spherical mirrors. Image formation by spherical mirrors. Very important questions will be asked here, and we have given you that how do we find out what type of image will be formed by spherical mirrors. To give a recap. I am just giving a recap. I am giving you a small recap, student revision, because this is important. Last time I have told you what are the rules which can be used in order to make ray diagrams for concave mirror. Yes or no? Tell me fast. So
Yes, sir.
how many rules I told you? Rules?
So 4 rules.
4 rules for formation of images by concave mirror. Rules for forming images, ठीक है? For concave mirror, we told concave mirror, and we have told you 4 rules. 4 rules. This is the first rule which is there on the screen. As you can say, a ray of light which is parallel to the principal axis. Ray of light which is parallel to the principal axis. But what happens to it? It will pass through the focus of a concave mirror. Is it clear? What was this rule? Rule 1. Am I right? Rule 1. So as you can see, this is a ray of light. It is coming parallel to the principal axis. It will pass through the focus. And in order to construct a ray diagram, how many rays we will use? 2 rays from the head of the object. Head of the object, as we have shown in the previous lecture for concave mirror. This is a recap. But if it is a convex mirror, then what will happen? If I use convex mirror, and you already know, student, what is a convex mirror? Convex mirror is a diverging mirror. Concave mirror is a convergent mirror. So if I draw the convex mirror, how it will look like, student? This was for a concave mirror. So if I use a convex mirror, then what will be the rule 1 for the convex mirror? How will we draw, student? As I said that we should try to practice and draw the diagram. Okay? As you can see, student, what is this? This is my, which mirror is this? Convex mirror.
So convex mirror.
Okay, very good. Be with me, student. So with the scale, you can draw F, C, okay? And this is your pole. This is your pole. Here the light is converged. You can see this is a convergent mirror. It is a convergent mirror, student. And what is this? Divergent mirror. Divergent mirror. Note down everything. It is important. So if a ray of light is coming parallel to this, student, what will happen? If a ray of light is coming parallel to the principal axis, what happens, student? In this case, what will happen? In this case, or this will appear to diverge from principal focus. This will, I'm saying, ray of light. Note down, ray of light parallel to principal axis, parallel to principal axis, will appear to diverge, from the principal focus, of a convex mirror. Is it clear?
Yes, sir.
Note down where is this focus? You can see, student. Here I am drawing a dashed line, and this is my, as you can see, this ray of light, it is parallel to principal axis. It is diverged, and it appears, student, it appears to diverge where? At the focus of the convex mirror. Note down, very important. All this we are going to use again, student. Let me change the color. Okay. So this is a case of a convex mirror. This is a case, it is a divergent mirror. First rule. This is my rule 1. Okay. What is this? Rule 1. Note down for a convex mirror. This was the rule 1 for concave mirror. You see the difference? This is a convergent mirror. Ray of light parallel to principal axis passes through focus. Here, ray of light parallel to principal axis will appear to diverge. Will appear to diverge from the focus of the convex mirror. This is the focus. Okay? Is it clear? Rule 1. Rule 1. Note down. Note down. Similar, you can see I am comparing concave mirror and convex mirror. But we want to see what type of image will be formed, what is the nature of the image, what is the size of the image, and what is the distance of the image from the object. These are the things which we told you in the case of concave mirror. Now let us see, students, this was a rule 2 for concave mirror. Now I am giving you, students, rule 2 for convex mirror. Rule 2 for convex mirror. Be with me, student. Be with me. Keep on drawing. Keep on making a drawing of all this. Now, how will you draw a convex mirror, students? My drawing may not be very good, but you can make better drawing than me, students. You can make better drawing than me a little bit. My pen is shaking on the board, which I have. Okay. All right, this is my convex mirror. Again, I draw the same thing, students. Line, hole, focus, and double of this, center of curvature, center of curvature. You see that in case of concave mirror, focus is to the right side. In case of convex mirror, focus is on behind the mirror. Behind the mirror, it is in front of the mirror. This is your concave mirror. And this is your convex mirror. Now, if a ray of light is directed towards the principal focus of a convex mirror, here what I'm saying, rule 2, if a ray of light is directed, it is not passing through, it is passing through, student, because the focus was in front of the mirror. It is directed. If a ray of light is directed towards focus of a convex mirror, then what happens, student? What happens when I say it is directed? Let me put it like this. I'm showing a dotted line now. Why? You can see this is the ray of light coming on convex mirror. This is directed. It is dashed because it is behind the mirror. If a ray of light is directed towards the focus of a convex mirror, after a reflection, what will happen? After reflection, what will happen, student? Will emerge parallel to the principal axis. Note down. Will emerge parallel to the principal axis. Okay? This is my convex mirror. This is directed towards the focus. Then what will happen at this point, student? What will happen at this point? This will become what? Emerge parallel to, this is principal axis. This ray is parallel to the principal axis. Is it clear? Tell me.
Yes, sir.
And important point to notice, note down everything and try to draw the images on paper by yourself. Then it will help you a lot. We are going to have MCQ question sessions. Don't worry. So, the laws of the reflection of light holds true for all spherical mirrors. And if I draw a normal here, normal 90-degree angle. If this is normal, student, normal line here. And then what happens? There is an angle of incidence and angle of reflection. This is your angle of incidence. This is angle of reflection. And angle I is equal to angle R. What is this law? Law of reflection. We told you 2 laws of reflection. Yes or no? So it will always hold true. That is why the ray of light which is directed towards the focus of a convex mirror. Focus of a convex mirror will emerge student parallel to the principal axis. Parallel to the principal axis. This is my rule 2. This is my rule 2. Note down, student. See the comparison between concave mirror and convex mirror. How to draw the diagrams? We are trying to tell you how to draw the diagrams of the concave mirror and convex mirror. See the comparison. Here, principal focus is in front of the mirror. It is passing through this, becoming parallel. Here, it is directed towards the focus and becoming parallel, emerging parallel to the principal axis. Any doubt?
No, sir.
Note down. Rule number 2. Next, student, see what happens. Rule 3 for this is our concave mirror, student. Rule 3 was used for concave mirror. What it says, a ray passing through the center of curvature of a concave mirror, what will happen? It is going back along the same direction after reflection. Okay? A ray passing through center of curvature concave is in the direction of the center, is reflected back in the same direction, as you can say. Why? Because this is normal, and you know, if a ray of light is passing through a normal, it is reflected back along the same direction, student. And let us see this rule 3 for convex mirror. Let me use a rule for convex mirror, student. Convex mirror. Okay. Just all right. Okay. What happened? Sharing. All right. So we are talking of the rule 3. I'm just trying to find my pen where it is going. Yeah, pen. I'm just waiting for my pen, student. Okay. So a ray of light which is coming through the center of curvature is reflected back along the same path for the concave mirror. That is rule 3. Let us see what happens in the case of the convex mirror. Let me draw the convex mirror, students. This is the convex mirror. This is my P, focus on the back side. Double of this is center of curvature. Now what happens in this case, student? A ray of light which is directed in the direction of center of curvature. That is rule 3 for convex mirror. Note down, students. A ray of light, what we are saying, a ray of light directed. Here I use the word directed in the direction. Directed in the direction of center of curvature. Center of curvature. ठीक है? After reflection, what will happen to this? Is reflected back. Is reflected back along the same direction. Here the center of curvature is in front of the concave mirror, so the ray of light is coming. What is happening after reflection? It is going back along the same direction. Here I am saying if it is directed, because this is a convex lens, so here I am drawing what is happening, student? Dash line from this is the center of curvature. What will happen? A ray of light directed in the direction of center of curvature. After reflection, what will happen to this? This was a ray of light. It is coming like this. After reflection, it is reflected back along the same direction. Can we see that? Tell me. Can you see that? If you draw with a scale, you will be able to draw better diagram than what I have shown. As we practice, you will be able to draw, because ray diagrams are very essential. Only if we can draw the ray diagrams, we will be able to find what type of image will be formed when I change the position of the object with respect to concave mirror or convex mirror. So the rules, we are giving rules for concave mirror, which we already did in the last video, and we are giving rule for the now convex mirror, because our today's objective is to find the image formation, what type of image will be formed, size of the image, real size, bigger or smaller, diminished or magnified, what type of size will be there, and whether it will be real or virtual image, or where it will be erect or inverted image when we use convex mirrors. According to that, we are using convex mirrors in our everyday life. Let me show you. So the rule 3 is clear. Then I proceed further. Draw the diagrams. Now I'm coming to the last rule. That was our rule 4, student. This is a concave mirror, students. As you can see, a ray of light which is falling on the pole is reflected in such a way that it makes the same angle with the principal axis. As the same angle is made, a ray of light incident on the pole at an angle angle theta, you write angle theta, is reflected back by the same angle theta, This was the rule 4, which we did not use when we draw the 7 or 6 cases for the formation of images by concave mirrors. Now what is going to happen? This, can I use the rule 4 for convex mirror? For convex mirror, student, I am talking of rule 4. The comparison is on the screen with you. This is my concave mirror. Now how do I draw the convex mirror? I always said that you draw this is my convex mirror, students. Okay, draw the 2 centimeters. Supposing I do this, then another 2 centimeter is my center of curvature. This is radius of curvature, is double of the focal length. For a small aperture mirrors, we already told you. Now what will happen, student? In this case, if the ray of light is incident on the pole, this is my pole. The ray of light is incident on the pole. What will happen? Is reflected back. If this makes an angle theta, it will be reflected back. What will be this angle? Tell me, student. This is the normal. This is the normal in this case. So what will be the angle? This one, student, will also be theta. Same angle. The incident angle and the reflected angle are equal, student. Angle I is equal to angle R at the pole. So this is the 4th one. What will happen if a ray of light, if a ray incident obliquely to the, then what is the rule 4? I'm using for the convex mirror, students. Convex mirror. I'm saying a ray of light incident, what we call this as obliquely to the principal axis, means it is falling on the pole. A ray of light is incident on the pole, what we call as pole of the mirror, pole P of mirror. That is what we mean by obliquely. What will happen? Then is reflected obliquely, student. Means what it means, student? The incident and the reflected rays follows the laws of reflection. The incident and reflected reflected rays, incident and reflected rays follow which law? Follow the laws of reflection. What will they follow? They will follow the laws of reflection. Laws of reflection. As I said, angle I is equal to angle R. So making equal angles with principal axis. Making equal angles with principal axis. Is it clear? So the four rules are clear, students, for the concave and the convex mirror. Any doubt here? Tell me. In all the cases, the laws of reflection are obeyed, which we told you. Only two laws of reflection were told. They are followed. And incident, at the point of incident, the incident is reflected in such a way. At any point, the incident ray is reflected in such a way that the angle of incidence will always be equal to angle of reflection. Is it clear? So in all these cases, note down. In all these mirrors, spherical mirror, concave or convex, the laws of reflection are obeyed. Laws of reflection are always obeyed. Is it right? So always angle I will be equal to angle R. This is very important point. Note down. So students, after these four rules are given, we have given these rules for concave mirror last time. Last time I have drawn the diagrams for the concave mirror also for different cases. I need not repeat that here, but you note down these rules for the convex mirrors. Because today our target is we have set up the target today. Our intention is we will focus and see how the image is formed by the convex mirror, and compare the difference between the image formation of the concave mirror and the convex mirror. As the object will be moved closer to the mirrors, spherical mirrors like concave and convex, what happens to the image? In a plane mirror we already know, and here we want to see what will happen. Okay, all right. So just to give a recap, last time I told you image formation by a concave mirror for different position. When the object was at infinity in the case of concave mirror, you know, the position of the image was at focus and it was highly diminished, point side, real and inverted. You already did that in the last video. We are just giving a revision for the concave mirror. Then for the concave mirror, I showed you when the object is beyond C, then you can see then the image is formed which is inverted. This is a diminished image, smaller in size, and it is between F and C. The image is real and inverted. We discussed it last time. Yes or no? Tell me. Any doubt here for the concave mirror?
No, sir.
So you can see in concave mirror what type of images are formed. A point image at the focus. When object is at infinity. When object is beyond C, then you are getting inverted and diminished image. And real images are always inverted. You have seen it. The size of the image has become smaller, diminished image. Then another case which we discussed last time, student, when the object is at C, this is important. When you will put an object at C in front of the concave mirror, you will always get an inverted image at the same point and of same size, and it will be real and inverted. Is it clear? So this is important point, that in the case of concave mirror, what we found, student? Concave mirror, when object is at C, then what happened? Where the image was formed at the C, at the same position. And what is the size of this? Tell me more.
So same size.
Same size. Such questions are asked in the multiple choice question also. That which mirror will form, you see, same size at the same point image, and the image will be real and inverted. So you will get real and inverted image. When in front of the concave mirror, you will put an object at center of curvature. Point to be noted is important. Such questions will be asked in the paper. Note down. Noted? All this, when I put star, they become important questions. Student, we should know what type of. The question is when an object is placed in front of the concave mirror. You can see when object was at infinity. Now you are bringing it closer and closer to the mirror, and what is happening to the image of the object. At first, when at infinity, focus and point image, then you are coming closer. Inverted image, you got inverted image and smaller. Now you are getting equal size inverted image at C. What will happen if I move the object now further from between F and C, between F and C? Again, we have drawn a diagram for that last year. If an object is placed, this is an object between F and C, in front of a concave mirror. Object between F and C for a concave mirror. What has happened to the image? Where is the image now? Tell me, it is beyond C?
Yes, sir.
Okay, such questions will be, the image is beyond C. As you can say, what type of image is this? Is it a diminished or enlarged? This is the object.
Sir, enlarged.
Enlarged image. Enlarged image. And is it, what is the nature of the image? It is real. It can be taken on the screen, and it is inverted. Real image is inverted. Always I am writing real inverted, real inverted. You know, in our eyes, which lens you have in your eyes? You know that the lenses, when I will discuss the lenses again, we will discuss the image formation. Do you know in your eyes which lens is present? Is a question in the paper. Human eye, your eye has a lens, yes or no? Which lens is there in the eyes? Which is convex lens. And it is forming an image on the screen, which is retina. What type of image is that? Real and inverted. But you see, you are seeing me inverted, or you are seeing me, are you seeing me inverted or erect?
Sir, erect.
Then what happens? On the retina, the image is formed inverted by the convex. There is a convex lens inside your eye. You will see, we will show you in the chapter of eye. But what happens? There is a pulse which sends a, which transmits it to the brain. What happens? The brain perceives it as we are. Again, the image becomes upright. Interesting about human eye. It's a camera. Human eye is a camera. You will see whatever cameras you are using. All right. So this is the knowledge is very important for us. And we are going to tell you what type of images will be formed in a convex mirror in a short period of time. All right. So with this already we know beyond C, enlarged, real, and inverted. What else we discussed in the previous class, student, in the last time? If an object is at focus, what will happen, student? Question is, if object is at focus, if object is at F in front of a concave mirror, then what is the nature of the image? Question is, what is the position of the image? Position. What we ask, position of the image, size of the image, and third, I'm talking of the nature of the image. What is your answer? What is your answer, students? This is the object here, what we have shown, AB. Now what has happened to this ray of light parallel to the principal axis passes through focus, another passes through center. They are parallel. So what will happen? Where will this meet?
Sir, at infinity.
At infinity. So the position is at infinity. This is how we write answers. Or if multiple choice questions are given, they will give you that which mirror is forming an image at infinity. What is the size of the image?
Sir, highly enlarged.
Highly enlarged. You are getting highly enlarged image. And what is the nature of the image? You are saying it is real and inverted. Real and inverted. All right, this we already did. Okay, just to recap. Interesting. I'm talking of the questions. What type of questions are they putting to you? Another interesting thing, if an object is placed between P and F, this is my principal focus, P and F. If object, this is very important question. If object is between P and F of a concave mirror, students, then what is the question? What is the position of the image? Position of image, size of image, number 2 question. And third, we are asking student, the nature of the image. Nature of the image. Tell me now what is your answer, students. If an object is placed between P and F of a concave mirror, what is the position of the image? Where it is formed, it should be shown by dotted line because it is not a real image. It is not a real image. So position of the image is behind the mirror. What is the size of the image? You can see object and size. It is diminished or enlarged. Enlarged. And what is it? This is virtual and erect. Now this is an important question. Can you tell me what is the main use of this? What is the main use of, here it comes the uses of concave mirror. What is the uses of concave mirror is an important question. So students, tell me, if you have a concave mirror, and you can see that if you are watching your face, as you bring closer and closer, if you are the object, if you are between pole and focus of the concave mirror, what will happen to your image? Tell me, what will happen to your image? What will happen to your image if you are an object? You are an object, student. Okay, and you are between P and F, in front of a concave mirror. What will happen to your image? Tell me. What will be the use of that? It's an important point. Can you tell me? What is your answer? You know, they are being used for this purpose. You have seen cosmetics. What happens? You want to see your face very clearly. So those girls are putting some lipstick or something. What type of mirror is that? So that they see a bigger face inside the mirror. What will be that mirror? Tell me. If I say shaving mirror, students, you have seen your father shaving, and what type of mirror should be it? So that he can see a bigger face. What will be that mirror? Tell me. What is your answer?
So concave mirror.
Concave mirror. You can see very clear and big face, students. So they can be used in cosmetics or in shaving mirrors. They are what we talk of the concave mirror. And that, you know, now the object is between focus and pole. If it is not here, then you won't see virtual, erect, and magnified images. Because concave mirror, you have seen about 6 cases I have shown that how different images are formed in the case of concave mirror. Now we will come to the question that what type of image is formed by the convex mirror. This, we have already given you the rules which were used. The rules which were used for finding images of a concave mirror. Out of the 4, I was using only 2 rules. When the 2 rays of light intersect, that is the point of the image formation. I was using head of the object always. You can see I am not using the tail, bottom. I am using the head, and then I am giving the image formation. So this is a very easy way of finding the nature of the image, size of the image, and position of the image for a spherical mirror. All right, now let us go to the question which we are coming. As I said, now our today's intention is how image formation by a convex mirror. How many rules I told you? Tell me how many rules I told you.
So 4.
4 rules. Okay, to be used for image formation by convex mirror. How many you will use for every ray diagram? Out of the 4, how many you will use? Only 2. Okay, we need 2 rules. When the 2 rays will intersect, that will be the point of image formation. Rule 1 is the first one which I always use. That ray is parallel to the principal axis, it appears to diverge from the focus. This is the rule 1 which I am always using. And the second one, Rule 1, I can use this rule or I can use this rule which we have shown. So 1, 2, 3, 4 rules are here. Here the ray of light is parallel. It appears to diverge from the focus, and if a ray of light is directed towards the focus, it will become parallel. It will become parallel to the principal axis. This is a rule 2. And another rule which I use a lot, this is when the ray of light is directed towards the center of curvature, it is reflected back along the same direction. So we have 1, 2, 3. This rule is hardly used. I won't be using much of this, so I'm going to take 1, 2, 3. These are the 3 rules which I will use to construct student, or to draw ray diagrams for image formation by convex mirrors. So this is my concept board. This is my concept board which I have shown. This is my concept board, student, in which I have shown you the rules which I will use for forming images by the convex mirror. Now you have already noted all this 4. Any doubt is there? Tell me. 4 rules. We have also shown you for concave mirror. Now we are coming to the question of image formation by the convex mirror. All right, you can sip water, student. Water has got energy. I always say, water heal me, and I sip water. Your throat, your body needs drops of water. And this water, 75% of the water, your cells of the body, they love water. Water has energy. Water has energy. We can heal it. So students, we are now prepared with 4 rules, out of which 2 will be used for drawing the ray diagrams. So which provide us valuable information about what type of image is formed, position of the image, size of the image, and nature of the image. These are the 3 questions which are asked repeatedly. I proceed further. Question is coming now before you, student. We want to find nature, position, relative size of the image formed by convex mirror. Why did I use the word relative, students? Relative size. What do you mean by relative size? Why? You have an object, whether the image is bigger than the object, smaller than the object, or same size of the object. So it is relative to the size of the object. So everything we are talking is relative to the object. If I am standing before a mirror, I have to see whether my image is same size, virtual, erect, or inverted, or what has happened to my image. So it is a comparison. When we compare, then only we say relative size. So it is a relative size. Got the point? Why I use the word relative? I'm comparing with the size of the object, whatever object I have taken. And you have been shown that we are using objects like this because it is easier to draw. And this is our head, this is your tail. So the first question before us is, student, question number 1 I am putting. An object is placed at infinity. We are saying an object placed at infinity. Okay? In front of a convex mirror. Which mirror? Convex mirror. Now you have to find the position, size, and nature of the image. Nature of image. What are the rules? We have the rules. How many rules? 4, but I said we will use only 2. So students, what we have here, we have learned to draw. This is my, which mirror I am drawing, students? Which is this mirror? Be with me, students. Which mirror is this? Convex mirror. With a scale, I draw, supposing 2 centimeter, then I have a C at 2 centimeter. The convex mirror, focus and center of curvature are behind the mirror, In concave mirror, they were in front of the mirror. And you are saying, okay, there is an object. There is an object here, students. What will happen to the object? If I consider an object, this is at infinity, student. AB. What is the distance at infinity? So what I will do, let me make it more simple for you. Infinity. So I am putting some dashed line. Does what happened? So let me use it like this. Some dash line I'm showing, and then this. Okay, I'm drawing like this, student. Dash line, because it is coming from infinity. So what we told you, the rays which are parallel to this, what happens to them? The rays which are parallel to the principal axis, what will happen to them, student? Parallel to the principal axis, they will appear to diverge from the which point? Focus. Yes or no? Tell me. Is this the correct image? Where will they be meeting? At the focus. So what will be the result of this? What type of image is there then? This is a ray of light, then it is coming. It is, this is, you can see how this parallel rays, they appear to be at the focus. This is along the normal, along the principal axis. This will go back in the same direction. So what is our answer, student? When the object is at infinity, where is the image formed? Tell me. What is the position of the image? Position of the image, student. Where is it? At the focus, at F. This is where the image is formed. What type of image is this? It is a point sized, very small in size, diminished, highly diminished. We call it point sized. Point sized. And this is going to be virtual and erect. Virtual and erect, students. Is it clear? You have noted? Tell me. As you can see, this is the object. These are the rays of light drawn to the scale. So when position of the object is at infinity, the position of the image, is at focus, and this focus is behind the mirror. It is a convex mirror. The focus is behind the mirror. Behind the mirror, important. This focus is not in front of the mirror. It is behind the mirror. Behind the mirror. Important point, student. And this is point sized, or we say highly diminished. Point size or highly diminished. It is virtual and note down. Note down, student, everything. The image formation by convex mirror, very important. Note down. Noted. Then I proceed further, students. Can I proceed further? Noted. Next question is coming before the screen. Now this is my convex mirror, student. If the question, draw the ray diagram when object is between pole, ठीक है, and infinity for a convex mirror. Question number 1. I'm saying putting question number 2. ठीक है. Find the position, size and nature of image. Nature of image when object is between P and infinity for convex mirror. For convex mirror. Okay? Note down, students. In the case of concave mirror, I have shown you. How many cases did I show you in the case of concave mirror, student? 1, 2, 3, 4. How many cases did we show? I showed you about 6 cases, 6 type of ray diagrams. How many ray diagrams I have drawn for concave mirror? Tell me from your notes. How many ray diagrams did I draw for concave mirror? 6 diagrams. But for convex mirror, everything is simple. I will draw only 2 ray diagrams. It's very simple. One I have drawn for the object is at infinity. That you are getting a point-sized image. Point-sized image. What you got is a point-sized image that was virtual and erect at the focus when the object is at infinity. Object is at infinity. Now, if any object is placed between pole and infinity in front of the convex mirror, what will happen? I will use the same rules. Only 2 rules I will use out of the 4. What I will do, the first ray, what will happen? First, if this is an object, student, this is my convex mirror. The first rule I always say, this is an object, student. So I am saying this is my A, this is my B. And this is my pole. And this is between pole and infinity. Infinity. This distance is posing infinity. It could be anywhere. The first light ray I take from where, student? I take parallel to the principal axis. Then it appears to diverge at which point? Here, this is my focus and this is my center of curvature. What will happen, students? You are drawing like this. And this goes like this. Tell me, am I right? It is diverging. It is diverging and directed towards the focus. So where is the focus of the convex mirror? Behind the mirror. Behind the mirror. This is my rule 1. Am I right? Yes or no, students? Be with me. Be with me. What is the second rule? I will pass the ray from the center of curvature. What happens then? Center of curvature. It is directed. This is my center of curvature, student. So what will happen? This is the center of curvature and this is. What happens, student? When a ray of light is directed towards the center of curvature, what happens? It is reflected back along the same line. Is it clear? Where they are intersecting? This is the point of intersection. Tell me yes or no. Tell me where they are intersecting. Behind the mirror. And student, this is the image. Now, what is the story? A dash, B dash. Can you see the image, students? Let me change the color if you have any doubt. Can you see the color, student? This one. Visible? Tell me. This is the image A dash, B dash. What has happened to the image, student? Where it is formed? What is the position of the image? Tell me. First question, position. What is the position of image when the object is between pole and focus? Student, what is the position of the image? Tell me. It is between P and, where is it? Between P and F. Between P and F. This is the pole and the focus. Behind the mirror. It is behind the mirror. Student, note down. Then what is the size of the image? Diminished. The image is diminished in size. The image has become smaller in size. Can you see it? Yes or no? And what is the nature? What type of image is this? It is virtual and erect. So students, we can see that in the case of the convex mirror, student, you can see what is happening. You are getting image which is diminished behind the mirror, virtual and erect, and a complete ray diagram is shown like this. This is the object and this is the ray. This is directed towards parallel to the principal axis, appears to be directed to the focus, and you can see that. And then what happens? You can see then this is passing through the center of curvature and it will be reflected back along the same line, and this is the image. This is our image, student. Object, image. Note down. So far convex mirror, the things are becoming very simple, as you can see. So only two positions we have shown for the object. Formation of image by convex mirror, only two. Concave mirror, I showed you 6 cases. You are always getting virtual and erect image, always getting. What type of image? Virtual and erect in the case of convex mirror. What type of image you are always getting? Virtual and erect in the case of convex mirror. Note down. Noted? Tell me, any doubt? So convex mirror is more simpler to draw. Nature and position, always virtual and erect image. We have shown you how to draw the ray diagrams. The rules have been clearly explained. Only 2 cases for the case of convex mirror. Interesting thing, here is a question for a student. Observe the image of a distant object, say a distant tree in a plane mirror. Could you see a full length image? Try with plane mirror of different sizes. Did you see the entire object in the image? Repeat the activity with concave mirror. Did the mirror show full length image of the object? Question 2. Question 3. Repeat the activity with a convex mirror. Did you succeed? Explain the observation with reason. What is your answer, student? What is your answer? Distant object. An object is at a far away distance. You use a plane mirror. Can you see the full length image? Full length image, I am saying. Then you try the concave mirror. Can you see the full length image? And then finally, you use a convex mirror. Can you see the full length image? In which case you will be able to see the full image, student. Tell me, what is your answer? In which case you will be able to see a full length image of a far distant object. I am talking of full length image of a far away. Okay? Observe the image of a far away distant object. Can you answer this question? Which mirror can give me this? You have 3 mirrors, plane, convex and concave. Tell me, can all the 3 mirrors give you full length image of far away distant object? Yes or no? What is the answer? Tell me, students. Only convex mirror. Only convex mirror will give you the full and will give you the full image of distant object, which mirror convex mirror. So even if you can see full length image of tall building tree in a small convex mirror, one such mirror is fitted in the wall of Agra Fort facing Taj Mahal. If you visit Agra Fort, try to observe full image of Taj Mahal. You should stand suitably at the terrace of adjoining wall. So you see that convex mirror is the only mirror which will give you full image of the distant objects. That is the reason, student, they are used as rear view mirrors, which mirrors convex mirrors. There's very important use of the convex mirror. As you have seen in your cars also, the rear view mirrors on the sides of the cars are convex mirrors. They give you full view of the back traffic while you are driving. This is very, very important, and note down this. Some of the uses of convex mirror, very important. Convex mirrors are used as rear view mirror. First use, as I told you, they give rear view mirrors of all the vehicles. They give a larger view of inside for security purpose in building and all this. So they will give a larger view of inside buildings for security purpose in building, hallways, in shops. There are convex mirrors which are used. They are also there in parking lots to make parking and taking of parking easy. In automatic teller machines, there is a convex mirror present close to the top of the machine. So it will give you a complete view. It can be used in sunglasses. It is used such that all the rays of sun are directed away from the person's eyes. And street light reflector. So the most important use, you already know, student, rear view mirror of all the vehicles. What are those mirrors? Convex mirrors. So you can get a complete and full picture of the distant objects in which mirror convex mirror, not in plane, not in concave, and in convex mirror. All right, students, this ends up the topic of image formation by concave and convex mirrors and the uses of the convex mirrors. Bye bye. Then I will see you in my next class.